Hey guys, welcome to my math corner. So today we are going to talk about set, including set notations and intervals. Okay, let's head into the things and cool parts. So we can take a look at different set notations. We can start by writing this one. So this sign means union. Looks like the capital letter U, right? Which means if we draw on a graph, then unions simply look like this one. Okay, so this is the circle A and this is the circle B. And strictly speaking, we need to say set A and set B. And you can clearly see that there are three parts within two circles. And the number two part is the overlapping part, right? Okay, now, so if we want to calculate the union of A and B, then we add all three parts together. 1 plus 2 plus 3. That is the shaded area, is what we are looking for. All right? Okay, let's move on to the next set notation. Number 2, intersection. I think this set notation is the one that you will encounter mostly in your later studies. This one, if we look at the graph again, still we have two sets, A and B. Then what do we have? We still have three parts, and this overlapping part is the intersection between the set A and the set B. Okay, by the way, set A or set B can be used to represent anything you want. Can be numbers, can be people, can be types of different activities. Okay, so just to mention. Right, and next one is what we've got for this symbol. For my personal habits, I used to call it belong to. For example, if A blah blah B, then I usually translate it into A belongs to B. Or you can use a more official way as saying A is an element or is a member of the set B. Okay. Now, and what about we add a cross? Okay, we add a line crossing this sign. Then it's the negative or opposite side. So not is not an element or is not a member of blah blah blah. Okay, simply saying is that. Next one. As for this one, so every time when you see n blah 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 following a set, then it means the number of, okay, the number of something. For example, A equals to 1, 2, 3, and 4. That is the defined set. I define the set A to be 1, 2, 3, 4. Okay, and n, the number of the set A equals to how many? 4, because in total there are 4 number in this set. Okay, very simple, isn't it? All right, now we should take a look at next part, complement. Okay, so complement is anything that doesn't belong to A, but still inside and within the universal set. So before talking about complement, Let me briefly introduce this one, universal set. Okay, what is a universal set? For example, here is a triangle, here is a rectangle, and we have many sets inside this rectangle, right? Different set, different circles can be used to represent different topics, different types of number. For example, this is about human, this is about animal, this is about plants, and so on. And you just define um, you know, variously. Okay, and the bigger rectangle is what? Is the universal set. And we also use the letter U, the capital letter U here to represent the set that includes everything. Okay? Maybe it can be um, you know, biological aspects in this case. Okay, now, so let me introduce this term, complement. For example, okay, there is a circle A, and the complement of A is the shaded area outside of the circle A, but still within the universal set. That is the complement. See here, if we got the case more complicated, there are two circles, circle A and circle B. So what is the complement? Still, don't be confused. Complement is still outside the circle A, okay? So we have to remove the overlapping area here outside the complement because it still belongs to or lies in the set A. That's it. Very simple, very straightforward. Another thing you have to keep in mind is that empty set. Okay, so the empty set actually is very easy to understand. See this diagram, the Venn diagram. By the way, it actually has a name for this type of diagram, Venn diagram. Okay, Venn diagram. In this Venn diagram, we can see that there is no intersection between the circle A and the circle B, right? We can call it disjoint set. So in this case, it's called a disjoint set. And we can also say that A intersects B equals to the empty set. Okay, equals to the empty set. Okay, no paths, no overlapping. Okay, so that is the definition for empty. All right, and another thing I want to highlight is subset. Actually, there are two different types of subset. The first one is a proper subset. Okay, a proper subset. For example, let me draw a Venn diagram for you guys. So a proper subset, for example, this is the circle B and this is a set A, right? So there is no path that overlap or can be the same as with B. Okay, so A is absolutely smaller than B. A is included, okay, in B. So A is a proper subset of the set B. And when you see this sign, A very easy way to remember is the opening of the sign always pointing towards the bigger or the larger set. Okay, the opening is always pointing towards the bigger or the larger set. Okay, now what if we add a line, okay, underneath this sign? It simply becomes that A is a subset of the set B. So we remove this word, okay? A is a subset of the set B. So there is a possibility that A and B can be the same. This is A, this is also B. So they are all representing the same thing. They are all lie within the same circle. They are equivalent. They are identical. That is saying subset. There's another possibility, equal. Okay, so we can use another example to illustrate this theory. Bigger, bigger or equal to. Smaller, smaller or equal to. Okay, so we can similaritize this thing into this thing and this one into this one. Okay, and in order to be a proper subset, which means for the larger set, it has to be at least one element that is different to the smaller set. Okay, to the smaller set. What does this sentence mean? For example, A is a proper subset of B, right? And A equals to 1, 2, 3. And B equals to 1, 2, 3, 4. Then all the first three terms are identical, but B has another element that does not belong to A. Then A is still a proper subset of B. So that is the case, at least one element, okay, different. All right. And another thing is that what if we reverse the sign? Okay, reverse the sign. It becomes to superset. Okay, superset. So here is the true statement. If what? If A is a subset of B, okay, if A is a subset of B, then B is a superset of A. Just reverse the opening direction. So please remember, the opening direction always pointing towards the larger set. Okay? All right. That's all about the theory, the knowledge points parts. Let me briefly introduce this graph to you guys. Before that, we have to get to know about different letters, what they are representing for. So the letter N usually represents natural number. For example, 0, 1, 2, 3, 4, 5, and so on. Okay, so it excludes negative integers. It only includes 0 and all the positive integers. That is natural number. Second, the letter Z or the letter Z represent integer. So absolutely, this one contains this one. Okay, this one contains this one. So we can say the set N is a proper subset of the set Z. Okay, all right. We can apply the knowledge points we just learned into this case. Number 3, the letter R represents real number. Okay, that's simply saying this one is even larger than the integer number. And the letter Q represents rational number. And lastly, we have complex number. We use C to represent it. Okay, in this case, I think you guys may be more familiar with it. Then we can take a look. The larger set for number is the complex number. All types of number lie within the complex number C set. No matter you are real number or imaginary number. So for complex number and imaginary number, we'll talk about this topic in the later videos. And next one, real number. It includes rational number and irrational number. For example, all of these examples I used are irrational number. Okay, next one, we have integers and natural numbers. So if we define complex number is the universal set, then all the 3 other sets lie within this universal set. Okay? So now let's see a practice question. You can pause the video for a few minutes if you want. So question A. Find the values of x such that x is an element of P. What does P represent? P is this equation. So simply we have to solve the equation to satisfy the condition that x is an element of the set P. It's a quadratic equation, very simple, right? So the answer is x either equal to 1 or x2 equals to 5. You can calculate on your own, okay? Right, so that's the answers. There are 2 answers for the question A. Number 2, question B. X is an element of the set Q. What does Q represent? Q is an inequality. Then let's solve the inequality together. Smaller than 10, then x smaller than 5. Okay, so is that the final answer what we are looking for? No, pay close attention here. If you stop here, then you got it wrong. So this only satisfies the set Q for this inequality. But the set Q also lie within this universal set. And the universal set says, firstly, x is an integer. And also 0 to 10 range. So the final answer is 1, 2, 3, 4. Okay, excluding the integer 1 and integer 5. Okay, so this is what we need to mention about. If we exclude a number, then we use the smaller or bigger sign, right? And if we draw on the number line, then we can see that we use the closing intervals, okay, for this case. But what if we have smaller or equal to, bigger or equal to, then we use an opening interval to represent. Okay? All right. Now let's move on. So for the question C, the intersection between P and Q. Okay, we can answer this question by inspection. Now, 1 and 5, 1, 2, 3, 4. What's the common thing? Only number 1. Okay? And now here, if we draw on the graph, when you get confused, always draw on the graph, okay? P and Q. So the complement of P and Q, P union Q, is the shaded area, right? How can we find out the shaded area? We just remove all the things, okay? So we draw a number line, okay? 0 to 10. And Q, okay, as for Q, smaller than 5, okay? So this is for Q and excluding 0, right? Okay, this is for Q. And for P is 1 and 5. So simply what we've left, we have left 6, 7, 8, and 9, excluding the number 10, right? Because it's smaller, it's not smaller or equal. Okay? 6, 7, 8, 9. Okay, so you can check your answers with mine to see if you got them all correctly or something might be wrong. Then you need to check your procedures, your processes to see in which part have you got it wrong. Okay, and then we can move on to the interval notation I just mentioned. So there are 3 ways that we can use to represent. For example, there are 3 types of brackets. The first one, curved brackets. Okay, look like this one. Next one, square bracket. Square bracket looks like this one. And we also have this one, usually for a set. Okay, so if, for example, set of real numbers, okay, real numbers, it lies between 2 endpoints. For example, I define the set D equals to, okay, firstly, X is an element of real number such that -1 smaller than X, smaller or equal to 1. Okay, so the universal set can be the real number, right? And this set D lie in the universal set. Okay, and this sign, okay, this vertical line, we often use it as such that. So x belongs, or x is an element of real number such that this is the range for x inside the set D. Okay, clear? All right. And how can we use the brackets to represent this meaning, especially for this inequality? Okay, actually, it looks like this one. So on the left-hand side, because it excludes the -1, so we use curved bracket. And on the right-hand side, because it can be equal to +1, so we use square bracket. Okay, so you can see that curved brackets is used for excluding a number. Square brackets is used for equal, okay, equaling in this case. And if we draw on the graph on the number line, okay, so in this case, we need to see that this one and this one, okay, as I mentioned before, if both endpoints are part of the interval, okay, so in this case, opening interval, okay, is for excluding, and the closing interval is for the case that might be equal. This is the opening interval. This is the open interval. This is the closed interval. Okay, so if this element is part of the interval, it's called a closed interval. If this element is not part of the interval, it's called open interval. Okay, that's it. And please remember, when things get to infinity, for example, x is bigger than a, nothing else, then we can see x bigger than a. So a is smaller than x, smaller or equal, no equal, is smaller than infinity. Okay, so when talking about infinity, there is no square bracket, which means you have to use a curved or round brackets here. Okay, a curved or round brackets here. All right, so let's see a question again. Let's practice a little bit. So if you guys get confused about this part, don't worry, you can leave your comments in this video. I will take a look and re-explain it again in the next video. So here is the question. Using the set notation to represent different statements and different sets, What does set notation mean? Set notation is different signs we just learned, okay? All of these signs are set notations. It's the language of set. So option A. In total, there are 52 members of the club. So what is the universal set? It defines, in this question, it defines the universal set to be the members of an outdoor pursuits club. So we can do different activities, but all of them are about outdoor activities club. So how can we use different notations? Let's find out. When talking about number, we need to use this one, remember? Okay, so the number of the universal set for question A, number of the universal set is equal to 52. Okay, simply as that. Question B. 35 members who go running. Okay, so for this one, we have the second set who go running. Simply, the number of running set equals to 35. Very straightforward, isn't it? Question C. Go running and cycling. Both running and cycling. What does that mean? Take a look. It's talking about intersection between one set and another. Then it's very straightforward. The number of the intersection between running and cycling equals to 21. Question D. Okay, question D might make you guys confused. Every member who goes running also goes walking. Okay, so if you are in a running activity, then you also in a walking activity. What does that mean? Do they mean equal? I don't think so. So which set notation can be used in this case? I suppose belong to. Is that right? No. Okay, so we can use this one. So running is absolutely is a proper subset of walking. Why is that? Running is a proper subset of walking because it says every member who goes running also goes walking. Okay, so running must be lie within the walking set. Okay, and another several questions to go on. Okay, now let's practice the drawing diagram, the Venn diagram. Okay, so please draw the two diagrams on your paper. You can pause the video now to draw them on your paper. And then we can see that how can we draw this set notation on the Venn diagram? Okay, firstly, we can draw it together. Let's shade the shaded area. A, the intersection of A and C. Where is that area? This one, right? So this one is the intersection between A and C. Okay, and then intersects the complement of B. What is the complement of B? It's all the area outside the circle B, right? All the area. So can you guys find the overlapping area? Yes, that is this one. Okay, so the result is that we remove this small part out of the original result. Okay, so the final thing is this one here, because we cannot include anything that belongs to the set B. Okay, next one. Question 1, draw a copy. Then you can pause the video to draw your answers and compare your answers to mine. So shade the region which represent those students who have a calculator and a ruler, but no protractor. So both C and R are included, but no P. So using set notation is C intersects R and what? And P complement, right? Let's find out. So the complement of P is all the area outside of the circle P. And what's the intersection area between C and R? C and R is this one, I suppose. Then we just remove the part that lie within the circle P. That is this part should be removed, right? So the final answer is quite obvious, is this one. Okay, question B. Shade the region which represent those students who have either a calculator or a ruler or both, but not a protractor. So in this case, still, we firstly draw the complement, okay? Draw the complement of the set R. And the first condition is either or, either a calculator, either a calculator, or a ruler, or a ruler, or both, okay, or both. So after removing all the parts in set R, oh, sorry, in set P, then we can do things in this way. So the final answer can be this one. Okay. So by using set notation, simply is that C union P, okay, and intersects the complement of, oops, I got it wrong. I misunderstood the letter here. I think it's this one, because we cannot include the protractor. Okay, so it's C union R and intersects the complement of P. Okay, now we can do the question reversely in the opposite way. So in this type of question, we draw a Venn diagram. But in this one, the Venn diagram has already been drawn. Then we need to, by inspection, we need to find out the set notation. It's very obvious, right? It has the circle A and the circle C. but no circle B. So firstly, we can write A union C, right? A union C is all the areas within the two circles. But we don't want the circle B at all, right? What do we do next? We intersect the complement of B. Okay, so every time, whenever you don't want a set, that is the complement of that set. Okay, remember the rule. So here is another very important rule you need to remember and notice. That is three rules actually. So if we have this one, oops, we have this one, then is shown on the result, we can see. Okay, very easy to remember. Brackets, okay, the intersection of A and B, then brackets, find their complement is the same result or equal to A complement union B complement. We just put this one on each set and then reverse the set notation. Easy as that. Okay, but this only applies to two sets. If there are more sets, things might be complicated. Okay, second rule. If A union B, then this one equal to, oh, can you guys guess? Yes, okay, it's equal to this one. So this is the result found after you draw several Venn diagrams, okay? It's just different order. So on the left-hand side, we first find out the intersection, and then we complement the intersection, right? For example, okay, so here is the circle A, and here is the circle B. Okay, firstly, we find the intersection, that is this area, right? And then the complement of the intersection area is all the area outside it, right? And it is the same result as this one. Okay, if we apply to it, okay, the intersection of A, okay, plus the intersection of B, you will get the same result after drawing several diagrams, okay. And next one, the A union B, the number of A union B equals to the number of A plus the number of B minus the number of A intersects B. Why is that? Okay, using the same Venn diagram to draw. So we have two circles still, and we have three parts, right? So the number of A union B is 1 plus 2 plus 3, right? Equals to number of A equals to 1 plus 2. Number of B equals to 2 plus 3. And you can discover that the number 2 part has been calculated twice. So in the end, we minus it. We minus the number of the intersection, that is number 2. And we cancel 1 number 2, which equals to 1 plus 2 plus 3. So the left hand side equals to the right hand side. Okay? Alright. So I hope you guys can enjoy today's video. And here is your homework. If you have time, you can practice a little bit more. So for this one, you can take a screenshot. And also for this one, okay? They are kind of in somehow they are similar to each other, but the question I've chosen are a little bit complicated than what I've shown to you guys in this video. And also this question, you can take a look. It's a past paper example. And this one, okay? You can also take a screenshot if you like. And I will upload and update the answers of these questions. If you need, you can leave a comment in this video below. Okay, the last one I've chosen for you guys is this one, in a copy of the Venn diagram. Okay, it's still drawing Venn diagrams, okay? But the set notations get more complex and more complicated. Okay, so that's all for today's topic. We are going through the set and set notations and as well as the intervals. So let me know in the comments if you think I can improve on anything I've shared. Also, if you enjoyed today's video and learned something new, don't forget to like, follow, and save it. So here's the deal. If this video hits 100 likes, I'll pick the most requested topic from the comments and make a special bonus video for you guys. For example, complex number, polynomial, or anything else. Okay, see you next time. Bye.